First lecture is very important. That is, it is the fundamental of all electrical activity in the body. So I start with the cellular electrophysiology. If you take the example cell, that is the rounded one, inside you will find cell has got different composition than outside, and inside you will see that the sodium is less, outside is sodium is more. Inside potassium is more, outside potassium is less. The difference is remarkable. Now take any cell in the body, you will find that inside the cell it is negative, it has got negative charge, and outside cell membrane it has got positive charge. So negative charge inside, outside it is positive. Now question is, one very important question arises, that why inside it is negative. Now inside it is negative because of few things. For example, sodium size is bigger and potassium size is smaller. So the bigger will be going out less, and bigger is going out or in with less because size is big. But potassium has got a smaller in size relative to sodium. Potassium size is small, sodium size is big. So the permeability through, that is crossing over cell membrane, is easy because potassium has got a small size. So potassium permeability is more than the sodium permeability. Now since potassium permeability is more, so cell inside will allow slowly potassium to go out, while the sodium coming inside will be in a lesser speed, will not be the same because of the cell size. Cell size sodium is bigger. So net result will be that positive ion, that is about of potassium, positively charged potassium, will leave in more number than sodium coming from outside. So naturally, when positivity is going out, so inside it will be negative. Inside it will be negative. The other thing is, why inside is negative? Because of the protein. Protein is in more concentration inside the cell, and proteins are negatively charged. So they are not allowed to go out because of the big diameter, big cell size of protein, and also it is negatively charged. So more protein is inside, so negativity is more. The third most important explanation is that on cell membrane there is a pump which is known as sodium-potassium pump. Now the sodium-potassium pump is working with the help of ATPase, energy with ATP, and this will pump out 3 sodium and pump is in 2 potassium. So 3 sodium will go out and 2 potassium will come in. So there is a loss of 1 positive charge. Potassium ATPase pumps out 3 sodium from inside to out and takes in 2 potassium into the cell. So there is a deficiency of 1 positive ion inside. So this is another cause why inside is negative. Then if you see, there is a strip shown here which shows that the positive charge is outside, negative charge is inside, charges are inside. And when it is this, inside it is minus 90 millivolt, 90 millivolt, and this negativity is generally most of the cell are minus 90, except for SA node and few other examples. Now this state is known as resting state, or say resting membrane potential. Resting membrane potential, if somebody says, that means he is saying that inside it is minus 90 millivolt. The another point is polarized state. The positive charge and negative charge are polarized, positive outside and negative inside. So this is also known as polarized state, polarized state. Now, then come to the second example. Left hand side, if you put one stimulus, electrical stimulus, what happens? At that point, there is reversal of charge, that is negative outside and positive inside, just opposite to the resting. Resting is positive outside, negative inside. In this condition, when we stimulate, the negativity goes out and positive inside is inside, positivity inside. Now this creates a dipole, and then this adjacent part will change again and adjacent again, adjacent again. So this way the impulse travel. The dark arrow shows the direction of impulse. So as the impulse is traveling, the distance is traveled, through distance it becomes negative outside, positive inside. This state is known as depolarized state. So depolarized means just opposite of normal. That is, outside will become negative and inside will be positive. Then third thing is how impulse progresses. If you see the first one, there is negativity outside, positive inside. Negativity, second one, same thing. In this way, the impulse is traveling, progresses. There is a progressive depolarization. So when we stimulate, why current from one place to another, how it reaches? Is reaches through progressive depolarization, with the help of progressive repolarization. Progressive depolarization. Progressive depolarization means the impulse is traveling by becoming negative outside, positive inside. So depolarization wave is formed, and this is how it travels. Now remember another thing. The distance it has traveled, the behind part is restored to the original state. That means positive outside, negative inside. And this is known as repolarization, going back to the polarized state. Repolarization. Let me sum up the thing which I told you. A normal cell has got positivity outside, negativity inside. How much negative? Minus 90 millivolt. Now this is separation of two charges across the cell membrane. That is outside positive, inside negative. That is known as polarized state, or this is also known as resting membrane potential. The place where we stimulate, the charges become opposite. That is, inside it will become positive, outside it will be negative. So this is known as depolarization. Depolarization. Outside, just opposite of normal. Normal is positive outside, negative inside. When we stimulate, inside become positive, outside it is negative. So this is depolarized. Third thing to remember, that how impulse travel from the one point to another. This travels in the form of wave of depolarization. The arrow, when it is going fast, it will cause depolarization, changing of the charges. So let me give you an example. Now in childhood you must have played with the blocks. You put the blocks straight up, 20 blocks, and you push one and all will fall, although you have pushed only one. Similarly, the impulse triggers by stimulation, and all impulse travel in the same fashion. So this is what is depolarization? How impulse travel from one point to another. That is, if you stimulate, the outside becomes negative, inside becomes positive. And this wave of depolarization travel from one point to another and leads to traveling of a stimulus. Third thing is that when the impulse has crossed some part, the impulse while it is going, it is causing depolarization. But the portion it has crossed, the impulse has gone from one point to another. Then behind, again it becomes normal. That is, positivity outside, negativity inside will revert. And this is known as repolarization. Repolarization. Let me sum up. Outside is positive, inside is negative. Outside, sodium is more than inside, while potassium is more inside and less outside. This causes, I have explained 3 reasons for why inside is negative. Then outside positive, inside negative is known as polarized state or resting membrane potential. When we stimulate, the inside becomes positive, outside becomes negative. And the impulse travel in this form, in the wave form, from one to the another. So what is this impulse? Impulse is triggered by a stimulation, but it progresses from one point to another in a wave of depolarization. So like a wave of depolarization from one to another. Then the distance it has traveled, the you stimulated impulse has come in the middle. So now the distance it has covered, that is distance behind, will reshuffle. That is the normal, that is positive outside and negative inside. This reshuffling is known as repolarization. So in the end, when charge reaches destination, again everything comes back to normal, and that is repolarization. The another very important fact I want to let you know is, say last part. You see, here is the electrode A. If you place electrode A here and you stimulate, the depolarization will go to the other side, and wave of depolarization. And this is another electrode on the other side which is receiving the impulse. So impulse, if you record by electrode A, that will record a negative wave. The wave going away from electrode will record a negative wave, while the electrode receiving will result in a positive deflection. So this is the essential thing that I wanted to record first.